thank you all so much for coming. We're really happy that we have this chance to present to all of you. We worked really hard, and we love our project. We love our team. So our team, I'm Matt. This is Ken, Quinn, Alex, Greg, and Brian. And we're going to be showing you PAL today. So before we get in and talk about all the stuff that we did and what it is, let's just see a demo right away. So over here, this is our PAL server. And PAL is our personal assistant, so I can go over here and I can ask PAL questions, like what is a PAL? So if I want to define PAL, I just do that.
Definition of PAL: a very close, intimate friend, comrade, chum.
And PAL also allows voice input. So what's the weather in Northfield tomorrow?
It's going to be clouds PM sun tomorrow in Northfield.
And yeah, so I'll need the voice input for now. I can also do things like query or look for things nearby me. So I can say find nearby pizza if I'm feeling hungry. And then PAL looks for pizza that's around and says, oh, I'm a fan of all these. And wow, some of those look pretty good, lots of stars. Wait, how much does a pizza cost? Cost of a medium thin crust pizza. Because I'm feeling kind of hungry, I don't know. But, oh, wait, that's really reasonable. Let's not beat around the bush. We're ordering pizza. So someone name toppings. Someone.
Mushrooms.
Pineapple and mushrooms. So PAL asks for my name and phone number and everything, but I don't want to take my credit card in front of you, so I already filled this all out. And PAL is like, wait for it. Well, there we go. So our pizza is officially on its way.
Meet PAL. PAL is your personal assistant on the web. You can access PAL from your computer or from your phone by visiting our website or by using the PAL iPhone app. What does PAL do? PAL aims to be a general-purpose personal assistant that is able to respond to a variety of queries in order to meet your daily needs. Now, PAL can respond to two types of queries. There's questions where the user is asking for some item of information, and there's commands where the user is asking PAL to take some action on their behalf. PAL handles both types of queries in the same way, which is by analyzing the query to identify a service that will be able to handle the user's needs. Now, understanding what services are in PAL is key to understanding how PAL works and how we decided to design PAL. We're going to talk about services in more detail later in the presentation, but for now, here's an overview of what they mean. PAL has 11 services, each of which encompasses code and data that is dedicated to handling queries within a specific limited domain. We were interested in handling services that would be useful to Carleton students, which is why we have a Bon Appetit service, a directory service, and a pizza service. Now, the thing about services is that each one is modular in that we can turn it on or off independently of every other service. And this modularity is a key advantage of our systems design. It makes PAL flexible in that we can decide what services to make available to any given user in accordance with that user's location and interests. This means that PAL can cater to locally relevant queries while remaining at the same time a general purpose personal assistant. Furthermore, a key principle in this project has been extensibility, and PAL's service-based modular design makes it very easy to extend PAL's functionality by implementing new services. Now that we've seen what PAL does, let's start talking about how PAL works. So here's a high-level overview. A query is initiated on the PAL client, which could be the website or iPhone app. It goes over to the server, which right now is running on the CMC. And depending on the type of query, the server will talk back and forth with external APIs before it formulates and returns a response to the client. Most of the interesting work happens on the server, and we're going to look at that in more detail. Essentially, the role of the server is to handle a single natural language processing problem, which is to take an English sentence, that is the query, and to try to understand it and then return an appropriate response in English. The server does this in 3 steps. There's feature extraction, classification, and server execution, which is the stage during which the server might talk with external APIs. So I'm going to turn it back over to Matt, who's going to talk more about the first step, feature extraction.
Great. All right, so feature extraction is where PAL takes the human language queries that we send to it on our web server or our iPhone app, and it transforms them into rigid structures. So down the line, the classifier and the services themselves have these rigid predefined structures. And the goal is that the bulk of the processing of the human query is all done in one place, so it's much simpler further down the road. And so what this sort of looks like at a high-level overview is if you're looking at the sentence, what is the meaning of the word happy? PAL sort of is like, okay, so you're looking for the meaning of happy. And that's just the general idea, but what the features it actually extracts are all of these. And so keywords are words that are like really important to the sentence, things that stand out. Nouns are people, places, locations. Tense is like present or future. Parts of speech are like verbs, adjectives, adverbs, and all of those are tagged in the full query. And we also have is question to determine whether it's a question or command. And then tokens, which are the words and punctuation that you've used, like nicely separated and split up. And so let's go through an example. If I'm looking for where is Friedrich Schiller, as a common Carleton student is wont to do, the keywords are where, because I'm looking for a location. And this is all the output that PAL gives me. This is just copy and pasted. The nouns, Friedrich Schiller is a person, tense is present, because I'm presently on the alert. And then location, because I'm wondering where he is. And then you can see all of the sentence tags that the parts of speech of the words in my sentence. So now on to classifications.
Now that we've talked about how that query is getting parsed, let's talk about classification. And at its core, classification is trying to answer a simple question of how do we sort the query into the right service so that the user gets back the response that they're interested in getting back. And our goals of classification, one, we want it, like the rest of the PALs, to be modular. We want it to be easy to add new services in and have those fit into the existing model of classification. And we want it to be easy for this classification to be tweaked and optimized so that adding new services does not disrupt the way things are previously being sorted, and no queries will be missorted when we add new services. So how do we do this? First of all, we use keywords. If you look back to our query of what's the weather in Northfield tomorrow, there are a few keywords that are of specific note from this query. First of all is weather. Weather, of course, will be a query that strongly indicates that this keyword should be sorted into the weather service. There may be other services that are also looking for the weather keyword, but weather is a much less strong indication for those services than it is for the weather service. Tomorrow is also an interesting keyword. It can indicate the weather service, yes, but it could also indicate the bon appetit service if you're looking for what's in a dining hall tomorrow, or if we had a calendar service, tomorrow might be a stronger indicator for that. So for the purposes of weather query, it's a weak indicator that is more likely to be present in different services. So how do we turn this into actually useful code? Well, each service has an individual file that looks something like this. This is a portion of the weather services file, which has a number of keywords and values mapped onto them. And you see that sometimes multiple keywords are mapped onto the same value, but still each keyword has an associated value, and that value indicates how strongly that keyword indicates that specific service. So for weather, we have high indications for weather and forecast, and some lower for high and low, and you see what it's like there. And how do we use these keyword values? Well, when we classify a query, it's sent to each service, and each service generates an individual confidence value. And how these confidence values are generated is simple. The query has already had its keywords tagged, so the service looks at those keywords, and it compares the query's keywords to the list of keywords that that service knows about. And for each keyword that the service recognizes, it adds the associated value to its confidence. Therefore, the service that reports the highest confidence for the query is the service that best fits the query and is the service that query is sorted into. An example of this, if we ask, what's the weather in Northfield tomorrow? These are the confidence results that we see from each service. You see that weather has very high confidence, and that some other services have lower confidence because of the other keywords present. If we ask, how's the weather in Northfield, we see that weather still has a high confidence. It's slightly less higher because we're not asking about tomorrow anymore. But the other services also have slightly lower confidences. The end result being that when you ask a question, the important keywords in that question have high enough values that the question will always be sorted correctly into the right service. Of course, we can't come up with these values on our own just by guessing. We're not magic. Even if we were magic, there could be problems if we added new services. The keywords associated with that service might cause things to be missorted, so we use something called hill climbing. Hill climbing is a process if you have an unknown optimal solution and a bunch of values that all contribute to that optimal solution. It's a way of arriving at the optimal solution iteratively. And the way we do this is we take our values and see what they give us. We distribute those values either by random change or by a smarter way. And we see if the end result is any better. And if it's better, then we take our better values and we repeat the process. And so we eventually move forward and forward until we eventually reach the optimal solution. Our hill climbing method is a little different because we don't have sort of a single value that represents the optimal solution. Our optimal solution is that all queries are being appropriately sorted into the right service. So for our hill climbing, we have a list of example queries for each service. And what we do is we run all these example queries, we run the natural language processing on them, we run the classifier on all of them, and we see which queries are being improperly sorted. And we know that when they're improperly sorted, the service that they should have been sorted into, the associated keyword values are too low. And the service that it was sorted into, the associated keyword values are too high. So we can step up the low keyword values and step down the high keyword values across all our services, across all these example queries. And as we repeat this process over and over, eventually we reach the point where all the queries are being properly sorted and all the values are right. So that is how hill climbing works, and that is how the classification works. Now we will move on to how these services actually function.
Thanks, Quinn. So now we're going to dive into what happens when a service is actually executed, specifically for the query, translate camarada from Spanish. By the time we reach the service execution, we're confident that the query belongs to the translation service, and we've already tagged the features, and they look something like this. So then our next step is to run NLP on the query to extract the details that we need, that the API needs in order to give us an answer. The first part of this is finding the language in the query. Languages are keywords for the translation service, and so they show up in our keywords. And like looking at these keywords, we see Spanish is a language, and we infer that the other one must be English because there's only one language in our keywords. But which one's the source and which one's the destination? We also saw from in our keywords. And whichever language follows from is the source language. That's intuitively how you figure it out yourself. So we look at the tokens and we see that Spanish is the word that comes after from. So clearly Spanish is the source. The next step, the final step before we query the API, is getting the actual word that the user wants translated. Just like a human, we can just take the word that comes right after translate, which is camarada, and combining that with the source and destination languages, we can send the query off to the API with the URL that looks something like this. So we plug those into our URL and send the query. Once we get a response from that query, we parse it back into human readable text, and then we return that to client, and then it ends up looking like something like this. Now Ken's going to talk about how we can extend that.
Cool, so that's essentially how the server works. And as we said before, the server's goal is to take a query, do something useful with it, and return an appropriate response. That was the essence of how we approach this problem. And now what if we take a step back and we ask, how well does PAL actually address the problem? Now when we ask questions like that in computer science, we're often asking questions about algorithms. Computer scientists will ask questions like, does this solution solve this given problem? Or does this solution solve this given problem Sometimes. Does it solve it quickly, efficiently? If PAL has solved the problem, it's not because we've implemented or invented some groundbreaking algorithm that's really good at handling user queries, because that's not what we've done. It's not because we've implemented some really hard natural language processing or some really hard artificial intelligence, because we haven't been doing any of that either. So to the extent that PAL's a success, it's a success because we've implemented a web application which is highly maintainable and which has a design which is highly extensible. How have we made PAL maintainable and extensible? The first way is, early on, we set a high standard for code reviews, which allowed us to write high-quality, well-organized code from the very beginning of the project. And Alex is going to talk more about that towards the end of the presentation. PAL is highly extensible, mainly due to its modular architecture. As you've already seen, PAL uses modular services. But PAL is modular more generally because we follow the design principle of separation of concerns. And you've seen that principle exhibited in the sections that you just saw. Feature extraction, classification, service execution. Basically, the server takes a hard problem, it divides it into smaller chunks, each of which is handled by independent pieces of code with well-defined interfaces at every step. As you'll hear Brian talk about, we've defined the role of the client and the role of the server with another well-defined interface in between. Essentially, this modular design makes it really easy to extend PAL's functionality in three ways. We can implement new services, we can implement new user-facing clients, and we can implement new natural language processing techniques. In the sections that follow, we're going to show you how PAL's modularity makes it easy to make PAL better.
So as Ken was saying, it's really easy to add a new service. So let's go ahead and take a look at what the steps need to be to make that happen. So what we're going to need to do is a few things first. First off, we need to find an API. There needs to be, if we don't have something that we want to do, there's no point in having the service. The second thing we need to do is implement 3 quick methods. It shouldn't be too bad. A lot of the work is already done for us. After that, we're going to need to update the hill climbing files. That way the services all get sorted nicely, and that's it. We're done. It'll be real quick. So finding an API. An API in this context is really a third party that has an interface that we can talk to and get useful information back. What that actually isn't really very important in this context because it'll work for just about anything. For the sake of this example, we're going to use the Ultralingua API to go ahead and try to do pronunciation on a computer. So that gives us an API, and so we'll go ahead and start off with methods. So the first method is really pretty simple. It's the applies to me method. And honestly, this is an entirely believable look at what the Python in a file would look like. All that we're really doing is checking to see whether or not the client is something that we're supporting. This lets us have clients or client-specific services. So if we want to have something that's going to take advantage of the fact that we have a full-size computer or have a phone call service for the iOS app, something along these lines lets us decide, okay, we can't do that on this other platform, and so we should make these decisions early. And doing this lets us not even bother to run the heuristics in the first place for services we don't need to. The second method is going to be the get confidence. And what this function does is it goes and basically does the heuristic things that Quinn was talking about earlier. You might notice that this is really just a call to the parent function, or the parent class rather. And what's really happening here is that function is written so generically that all of the services can just use the same thing, which is really pretty cool. And what that lets us do is, have a bunch of services and not have to rewrite code every single time. It needs a little bit more information, and that information is going to be in a values file, which is going to look something along these lines. Same thing that Quinn was talking about. We have words that are either indicators or contraindicators of the service that we want, and values associated with them for how strongly they either indicate or disindicate whether or not we should be using the service. In this case, speak should be rated fairly highly because that's what we want to do. Translate should be highly as well, of various languages, so on and so forth. So that's 2/3 of the work done. We're chugging along pretty quick here. So the last method that we need to do is the go method. So the go method is where all the interesting work goes on, and we've got it split up into a few different parts. So the The first thing we're going to need to do is take a look at the natural language. We're going to have to do the actual parsing to get the natural language out so that we know what we want to get. We're going to have to do the actual query, in this case the ultralingua, and finally we're going to have to generate some natural language for our output. So let's go ahead and take a look at the NLP first. So the NLP function is basically extracting from the previously done, in the feature extraction step, we just want to pull out the bits that we care about. And that's relatively straightforward because we know what we're looking for and it's there already for us. So in this case, we need a source language, we need destination language, we need a word, and then we can go ahead and return it back to our previous function. And so since we've gotten all of our information in a nice little package for us, we can go ahead and pass that into the actual API call, which is going to be in this function here. And so this is also really straightforward. We have an API out on the internet that is accepting bits for our URLs. We put in the bits that we want and then send it off. The internet gets our answer for us, and then we are going to return that back to the third function and move on to the last step here, which is generating our natural language. So the make language function basically checks to see, we need to check and see what our question is specifically. You don't necessarily need to have that figured out yet, and you need to have your question figured out in order to make sure that your answer adequately answers it. Most of these APIs are going to give us back things that we don't need in addition to the answer we're looking for, and so we want to make sure that we're just giving back the answer that we're looking for and not extraneous information. So that gives us most of what we need to do. So there's a few steps that need to get done to finish things up here. The first is we need to make heuristics happy with us, and so that means that we need to add some examples to the hill climbing file. These are just things that are using how is this service going to get used? And so any of these, either of these examples would work, and so on and so forth. You want to make sure that there are enough of these so that the hill climbing will actually climb on the service well. After that, we need to rerun the hill climbing so that the relative values of the services are reasonable, and that, that's it, ta-da. So after seeing how easy it is to do modular services, let's check out how modular the clients are.
So, thanks. So far we've talked about really only what's going on the server. But that's not what the end user sees. The end user is going to see something that shows up on a pretty website or a mobile app or what have you. You can think of a million different places to put PAL, and it's all possible with this large extensible API. So right now we're going to be talking about kind of this chunk of the picture. We saw a version of this before. And so you're sitting here on the client. In this case, we could be a desktop computer. We're going to ask PAL a question. So is it cold in Northfield? PAL's going to get the weather from a third API. That's going to return a response. PAL's going to format it and send it back to us. So let's talk about this chunk here. So we've defined a simple REST API. For those of you who don't know what it is, a REST API is a way for a client to talk to a server, kind of with a little bit of human parsable text, and we just do it with some URLs. So you send a post request to this address here, and we have a few parameters that go along with it. So first, we have a couple required parameters. These are pretty obvious. Query and client. So query is literally the words you type in or say, or your question or command to PAL. Client is the device you're using to make this request. So this could be web, this could be iOS, which are the two we have now. In the future, you could make as many as you want. And this will, as Greg was talking about before, this will inform PAL whether or not each service is relevant to your question given your client type. Then we have a couple optional parameters. So one of them is client data. This is data that the client can provide on behalf of the user without the user actually inputting anything. So right now this is used for geolocation, so for getting weather or getting like restaurants or things from Yelp around you. Your client can figure out where you are and send it off with your request, and that will be able to use that to return you relevant results. We also have user data. So you saw this before when Matt ordered pizza. This is data that PAL will ask the client for the user to input. So you send PAL a question, hey, order me some pizza. PAL will respond, all right, I can order you pizza, but please input your name, your address, etc., so we can make that So once you've asked Pal a question, Pal will process your input and return you an answer. In the format it'll return, we return a JSON, and I'll show you an example of that in a second. And you're going to get some status code indicating whether your result was a success, or whether your question has been answered or not, or if you need to do, or if your client needs to do something else like get your location or post to Facebook. We also return you a summary, which is, hey, this happened, and this will be read aloud on the client if you have that enabled. And we also have a data field, which can be HTML, and that will be rendered. So in the Yelp example we saw earlier, like list of restaurants would have been the data field. So I'd like to demo now a tool we have called Swagger. And Swagger is it's a way for us to essentially talk to Pal, pretend to be a client, and see what Pal outputs. So I have here, I can ask it a question. So I can ask Pal, here are my parameters. I have query, client, user data, and client data. I can ask Pal, I can say, hey, what's the weather in Northfield like? And sure, I'm coming from the web. And I can try it out, and Pal will return me a result. You can see that. It'll say, hey, status 1, success. And here's the weather in the summary field. Now, if I say, hey, just what's the weather? Pal, and I send that, Pal will say, okay, I can get the weather for you, but I need more information. So that's what this needs client tells us. It's going to say, hey, I need your location, and it'll give you a message that can be displayed, that the client will display, and you can't determine your location. So for example, if a user has denied location services from the browser or your iOS app, it'll show this message. Otherwise, it'll figure out your location and send that back to Pal to get the response. Then, if I just say, like, weather in Northfield, this is actually an interesting bug, but it illustrates status code 0, which is error. And what happened here is I typed weather capitalized, and there's a bug with some of our natural language processing libraries where it thinks weather is a location, and so it's trying to find weather in weather. And that's not a thing that can happen, so it gets confused and it says, hey, there's an error, status code 0. And finally, if I say post like hi from Pal to this will again send to Facebook, I'll get a different response that will say, hey, like this is telling the client, hey, can you post this to Facebook? You need to post. This is the message you should send. So I like to demo the Facebook service right now because what's interesting is that this is all happening client side. So if I open a new private window, so I'm not logged into Facebook, I can say post hi from Pal, and it's going to tell me.
I can post. You will need to log into Facebook.
So it's going to tell me I need to log in. And the reason it's telling me this is because all of the Facebook, all of the total interaction between Pal and Facebook is that it processes it, it says, okay, like the string hi from Pal should be posted to Facebook, and then it returns to the client, hey, can you post this to Facebook? And the advantage of this is that we are never actually managing user logins. All of this is happening client side, so Facebook is managing the logins. So then if I go and I hit login, I get Facebook's nice little window, and I have a demo user set up, so this is their fake email. So I can go ahead and log in, and no, I don't want to say the password, and so I'm going to go through Facebook standard authorization procedures. And
Okay, I've posted that to Facebook.
now, so Pal has, so now this all happened in my browser, like on the browser side. This is a JavaScript thing. Nothing happened on this Pal server. And so you can see if I go back here, I can log in as my fake test user. And ta-da, there's a message. So that's cool. And in order to implement this, we have a couple clients, like I said before. We have web and iOS. And it's really easy to implement a new client. All you have to do to handle the majority of queries is just to handle displaying some HTML and make a network connection. And so on iOS, this means just filling out a web view. On the web, we clearly have a web page. You can render arbitrary HTML at will. And so if you want to make a new client, really, all you have to do is do that. And we also have, as you saw before, we have voice output in Safari, our iOS app, Chrome, and that includes on Android. Safari and iOS actually does have voice output, but it blocks you because it needs to be initiated by the user, and when we send a request to the server and wait for it to come back, like enough time has elapsed that it thinks that we're just like trying to randomly talk, and it blocks us. We also have voice input on Chrome, and the reason for this is that voice input, it turns out, on the web is a really unfinished, it's an unfinished API. Google has kind of jumped the gun and implemented this, and it's also really hard to do good speech recognition. And so what happens when you talk to PAL is Chrome is like sending your audio stream to Google. Google is transcribing and returning you the text. And no one else has done that yet. This might be a thing that can change in the next year or two, so if that does change, PAL will get that feature for free on new browsers that support that. So yeah, as I said before, we also have a couple other actions that you might need to implement if you want to write a good client that has all the features that we showed in the web browser. Our iOS app also includes them. As geolocation, we use the web API for geolocation in the browser, core location on iOS. The post to Facebook service, Facebook has SDKs for any number of platforms. On the web, as I said before, we're using the JavaScript SDK. That's all happening on your browser side. On iOS has a built-in Facebook API that Apple has provided to developers that we take advantage of. We also have one more thing, which is the debug mode. And so the debug mode is a way it's been really helpful for us to develop like services. We can keep testing queries and see kind of where the natural language processing is having issues, or why a service isn't getting sorted into the correct request when it isn't being sorted into the correct service. And so what we have here is I've asked whether tomorrow in Northfield. You can see it's cut off a little bit. But you can see each stage of the execution. So first here we just tokenized and we've done some tagging of our words. Then next up we have the same information, but we've also added features. So you can see here Northfield has been tagged as a geopolitical entity. That's what GPE is. And this one we have tried to do the classification. You can see the confidence values here. And this is the full execution. And so here we can see we have executed, result would appear down here, and we've executed the thing and returned it back to the client. So that was really helpful in helping us debug. And so now Ken is going to talk about the queries.
All right, so thanks to separation of concerns and thanks to our well-defined interfaces, it's easy to extend PAL with services and clients, as Brian and Derek just described. But it doesn't end there. It's also easy to implement new kinds of natural language processing, and I'm going to briefly run over one kind that we've been experimenting with, which is something that we call domain-specific query languages. A couple of ideas led us to DSQLs, and basically, as you see when we talk about services, there's a lot of natural language processing work that happens within service execution, and it'd be really nice if we could take those NLP rules and extract them into a common format that doesn't need code, so that when you want to write a new service, you actually wouldn't have to write any NLP-related code. Secondly, to handle some queries really well, it would be a big help to use syntactic information, which would allow us to identify what roles different parts of the sentence are playing in relation to the intent behind a given query. Let's look at some of the ways in which we might do that. So let's say we take this movie query, and a key part of understanding the intent behind this query is to understand where the title of the movie is. So we're going to try to figure out how we can use syntactic information to figure out what the title is. And a basic start is that also imagine it comes in through voice input, so we don't have proper capitalization, and we might not be able to punctuate it properly. So it's going to look like this. It's a string of lowercase tokens. Now the first thing we might do is we can give it part of speech tags. This might look familiar because this is exactly what happens in the feature extraction stack that we talked about earlier. If you really want to use syntactic information, we can take this a step further with a more powerful tool. This is what you get if you fit through a statistical parser. And the statistical parser uses probabilistic language models in order to identify the most likely parse of a given sentence. If you've taken a linguistics course on syntax, then you've probably seen trees pretty similar to this. And basically what's going on here is the part of speech tags are here along the bottom. And then above that, we have tags of other linguistic structures that identify the ways in which those party speeches come together in a larger structure that forms a sentence. So ideally what we want is we want the title of the movie to be represented by a single entity in the tree. As you can see, the parser finds the noun phrase, A Space Odyssey. But unfortunately, it thinks 2001 is part of an adverbial phrase, and it puts it in a completely different branch of the tree. So the problem is, the statistical parser is based on a large corpus of really general text, and that general text is kind of too general for our purposes. So this parse tree might be useful if we were dealing with general text in conversation or general text, basically, but we're dealing with a much more specific domain of a much more specific kind of language. And we're going to need a different language model to really handle that well. So one option we could consider is if we had a big corpus of the kinds of queries we want to handle, we could train a parser from the ground up so that it would learn a language model based on the kinds of things we wanted to identify. The problem is we don't have that kind of data. Another approach is to design our language model from the top down instead. And that's the main motivation behind DSQLs. This is the parse tree that you get if you run the same query through the movie DSQL that we've implemented. You can see that title is identified as a single entity and it's labeled conveniently with the label title. How are we able to make this happen? Implementing a DSQL in PAL starts with writing the rules to a context-free grammar. This is a small portion of the movie grammar file. And basically this file describes a context-free grammar, which in turn defines the language of all sentences that we're going to identify as queries relating to movies. It takes some NLP work to make these files useful. And basically what we've done is we convert the grammar to Chomsky normal form. That allows us to run the CYK parse algorithm, which allows us to parse incoming queries in polynomial time. And finally, we convert that parse is a parse tree, which is under the Chomsky normal form grammar. We have to take another step to convert it to our original grammar so that we have the labels that we are expecting, which are the labels that we wrote our original grammar with. And this is going to be very helpful for extracting semantic information. So the real advantage here is that all of that NLP code is common among all services. What does it look like now if we want to write a new service, for example, the movie service? What kind of code do we have to write if we want to find the title in a query? It looks like this. It's one line. And that's the power of DSQLs. It's that we've standardized the NLP, and it makes the server execution code much shorter. It makes it more maintainable, and it's extensible because if we want to extend the kinds of queries that are handled by our grammar, all you have to do is add rules to the grammar file. It doesn't take any additional code to extend into the language. Let's see a couple demos of what this achieves. What year was Cloud Atlas?
Cloud Atlas was in the year 2012.
Name all Wes Anderson movies.
Bottle Rocket.
So DSQLs are pretty robust, and they're especially helpful when important information in the query can only be identified in relation to the other words in the sentence. We think that PAL has a lot of potential to continue to get better through techniques like this. And I'm going to turn over to Matt, who's going to talk about some of the challenges that we face in bringing PAL to the point it's at now.
Great. So we faced some interesting challenges along the way. PAL wasn't always telling us the weather or posting to our Facebook or talking about Wes Anderson. So some of the challenges we faced were the server design, the NLP, the flexibility of the service as a whole, and then finally external APIs, when the user says something and PAL has to talk to the rest of the internet. So in server design, the whole design of the server has really been a giant balancing game. And so the server API we want it to be flexible in that we want down the road PAL to just be able to do anything. So like anything we can imagine in the future, we want that to just be in our API. But at the same time, if the API gets really bulky, it's hard to maintain scalability of clients. The more things that the server is allowed to like tell you to do, the harder it is to implement that. And so this is things like posting to like external actions, like posting to Facebook, and things like getting location data or user data. And so this is a balance we've been trying to strike. Balance of services between incorporating domain specificity versus the modularity and ease of creation. And this was a challenge that we faced a lot along the way. I'll talk about that more when we get to the challenges with the NLP. But essentially, we were trying to figure out things that all services needed, and then like each of the services would need to do more on top of that. And so how we've kind of overcome this is with the DSQLs. And so that leads into the NLP challenges. And so we want all the features we get in like the feature extractor and steps further down to be applicable to all services. And we really want to avoid computing things that are later end up not being used. And so this was sort of a back and forth between like, oh, what services do we have now? What are they looking at? And like, what is the feature extractor doing? Does it need to do more? Are things not being used at all? What's happening there? And then also the natural language generation was a challenge. And so we get responses from our external APIs, but like this is all XML or JSON, or worse, we're parsing web pages and it's like HTML and JavaScript. And so it's just a mess, and we have to be able to figure out how to tell something to the user that they can understand. So if I ask like, what's the weather? I don't want like this giant like weird garbage. It's like temperature this, snow this, blah, blah, blah. I want like, oh, it's nice and sunny and probably cold. And so the natural, and also we had to agree with the user input, so like things about tense, about the objects who you're talking to. And so that was an interesting challenge, but I hope the demos you've seen today have demonstrated that PAL does seem pretty flexible and the responses are what you might expect in a real conversation. And speaking of flexibility, we also have to accept various phrasings from users. When we're putting this like out there, you know, all of us know what PAL can do, but like if someone just goes to like our website and just like, oh yeah, give me pizza. Like we have to be careful with something like, what is Alex Simonides' phone number would work. Something like, give me Alex's digits. Like, that's crazy, but that's something someone could ask. And maybe even more reasonable is like, do you have Alex's number? That's something you would ask a person in real life, but it's something that's difficult, the challenge that we've had to face when we're implementing these on PAL. And then finally, APIs. We've had some difficulty with the APIs we use. One specifically, which is BoneFD doesn't have a real API, and so we would scrape this from their website, which was like pretty nice. It was difficult to get it working, but then their website changed. This was a 2-term project. The website literally changed 3 times. And then also the Domino's API, like the keys to the topping codes, so it's just ridiculous. Like sauce is X, and then marinara sauce is like XM, and then white sauce is like XW, so you're like, okay, and then barbecue sauce is like B. So all of that is like really logical and makes sense. And the data format is ridiculous too. So we've had to like struggle with this when we're like talking to the rest of the internet. They don't always like to play nice with PAL.
Of course, PAL does a lot of great things. There's a lot of great things that we'll do with PAL in the future. First of all, add more services. We've talked about how easy it is to add services, how there's a great variety of more services we could add. This is an obvious place that we'll take PAL in the future. We've also talked about the new natural language processing, incorporating more of those context-free grammars to make our existing services better. That's another thing that we will be doing with PAL in the future to be better able to handle a wide variety of queries. Of course, there's a lot of stuff in client interaction that we can do that's really interesting with PAL. For example, we can allow the client in the future to select what services it doesn't want to get results from, allow the user some measure of control over their results. On the same note, we can allow the user to retry queries if they are not satisfied with the output that PAL gives them, to see if the next best service gives an output that's more in line with what they were looking for. And finally, in the future, we can save past queries so that PAL can have what we would deem a dialogue with the user. For example, if I asked, what was Ken Schiller's phone number? And Pal would give me his phone number, and then I asked, what about Matt Cotter's? And Pal could remember that I am asking about phone numbers in the previous query, and then give me Matt's phone number. So those are all interesting places that we'll be taking Pal in the future. And of course, there's a lot of reasons that Pal is in its current place based on our development process.
Yeah, so now I'm going to talk about some of the decisions we made really early on that really helped us build PAL in the way that we have them now. Code quality was kind of a big emphasis for us. And the way we ensure this was by choosing Python, which is a language with a very strong best practice, which is defined by PEP 8. And we chose the Flask web framework for our server, which is very extensible and modular, and as Ken went into at great depth, that's something that we wanted to have for PAL as well. And we chose Git for version control for a lot of reasons, but the biggest would be like branches. They allow you to work on your part of the code without messing anybody else up. As much as you want to ensure quality, you need some way of enforcing it. And so Git hooks were one way that we did this. Git hooks are kind of a neat feature of Git that allow you to have scripts that run automatically based on some action. So for example, when we try to commit code to Git, it'll run this script that goes through and basically tells you whether or not your code meets our standards and won't let you commit otherwise. And another way that we ensured code quality was through pull requests, like Ken talked about earlier. GitHub has this really cool feature called pull requests that allows you to put your work up there for your teammates to look at. And this allowed us to make sure that all of our code had been seen by at least 2 members of our team, which really played into team communication, because it meant that a lot of people were aware of what was going on. Another valuable tool that we used for communication is called Slack, and it's a messaging application that, well, the tagline is, put all your team communication in one place. So they have channels that you can use to separate conversation threads. And it was really helpful to us because it allowed us to basically stay in constant communication. We have probably over 100 messages per day on one Slack channel, and there's about 10 of them. And that was really valuable for us. Also, there's a GitHub integration for Slack, so all of our activity on GitHub was automatically posted to this one channel, which gave us a history of what was going on in our repository. Lastly, I'd like to talk about infrastructure decisions. So, as Ken said earlier, PAL lives in the CMC, but we also run a continuous integration server that watches GitHub, and for every new change, automatically pulls it to the PAL server and restarts the server, which meant that all of our latest changes were live on pal.rocks, and we're live on some server somewhere. And so we could instantly see if they were actually working. We'd like to give special thanks to Jeff Ondick, our advisor, for coming up with a really cool comms topic. All of the CS faculty, our audience, you guys, especially the people who came to our practice talks and gave us feedback the last couple of nights, and our friends and family for supporting us through times when PAL was less awesome. Thank you guys. Are there any questions?
Yeah, so what does it look like if you ask Pal a question that like goes to the wrong service? I'm curious what that is.
We have a great example of that. We're pretty good at picking services right now.
Yeah, so services, I mean, actually though, the number of times that things get sorted into wrong services isn't, I mean, I can't think of a good example query that'll
Actually,
go wrong spot.
line bars, capital F.
Yeah. No, what about 4 years? So If we find bars, yes?
Yes. So the problem here is that it sees these two capitalized words next to each other, and it thinks that must be a person. And so it tries to send that to StalkerNet right now, I think.
Unsurprisingly,
Unsurprisingly.
my person doesn't attend Carleton College.
So I'm very interested in your modular structure and your pipeline architecture. It's really cool. I'm wondering though, that when you in the first phase try to filter out some of the services and then feed the results into the algorithm which uses the hill climbing algorithm's results, I'm wondering if there might be some problems with the correctness of that, because the hill climbing was with respect to all possible services that you filtered from.
The filter that's used is on an individual query basis. For example, if we had a service that made phone calls, you wouldn't make phone calls from the web client. So that filter does not apply for the hill climbing. The values are established beforehand. True, if you're trying to use this fictional phone service on a query from the web clients, the results might not be satisfactory, but ideally you would return, in that case for that query, return a response saying, we can't help you, use a different client. Though we could also potentially route it to a different service if it was, for example, a query that would actually potentially work for a different service.
So when you order the pizza, there's a bunch of information about like 10 or 12 fields you have them in. Say, do you have currently, or are you intending, say, on the iOS app, for example, to store some of that data locally so that you can not have to put it in every time?
So not currently. It's certainly something that could be implemented in the future. I mean, right now, all they have to do is try to order the pizza, the server says, hey, I need like all this information. And so, yeah, it displays that form on the web, but theoretically, if you are mobile and you get this response that says like, hey, I need like all this information, the iOS client could pre-fill it, and in theory, you can use something, if you open your credit card file on your phone or whatever, to buy it like that way as well. But right now,
And also with that, we were a little worried about storing like some of the user information, like credit card sensitive information. I get to that end as well. Those are all removed when we log these on our server.
Are you guys making any compromises in the NLP to actually get the faster turnaround? Or is it just able to?
NLP is running.
Yeah, NLP is running.
I mean, there's some lag from parsing things that isn't great, but most of the issue is talking to the third-party APIs and then having them come back to us.
So you've identified as one of your biggest concerns as scalability, is specifically scalability with the number of services. And I'm wondering if you've had any thoughts about trying to make like a hierarchy of services in order to make it better. Like for instance, the decisions, you go into a certain part of the hierarchy when you think that the queries are related to social media, and then you have that subset of all of your services that are just social media related services.
Ideally, the way that the keyword selection is constructed with the hill climbing is that shouldn't be a problem, because yes, some of those services might share similar keywords, but if there is a way to distinguish them, and we have the example queries that run the hill climbing, that way will be clear so that all queries that should be sorted are properly sorted. The hierarchy is not necessary for proper sorting.
And I get that, but I'm wondering about if it's useful for maybe limiting some of the different.
So more precise answer. So if you have a bunch of social media services, they're going to have many similar keywords, and so when you run the heuristic, they're going to have similar values, but the one that you're looking for is still going to be higher because you were specific enough in your query to specify that service in the first place. And if you weren't specific enough to specify a single social media service, then a human who's listening to you isn't going to know what you're talking about either from that one piece of information.
If you're talking about limiting the domain though to like improve like optimization there, It's not something that that's implemented right now. We haven't really talked about it. But with the structure, I can foresee that it wouldn't be very difficult to add on.
I have a request for Pal. Open the hot bay doors, Pal.
Anything else?
Where's the pizza?
Probably use outside whites would be my guess.
Yeah, depending on the delivery person, they don't come to the room, and I wasn't checking my phone, so I don't know.
What is the default pizza option? Like if you just say order pizza, which place does it go to?
Domino's.
Yeah, it,
The closest Domino's.
yeah.
Cool. Other questions for Pal?
Caveat of it might break. I mean, it might.
It'll give you a bad responsible break.
Okay.
I saw that you guys have that jokes category. Just, do you guys have any fun examples of video footage and other things?
I believe.
Weird to do well there. I want to hear the British voice reading that.
Will conflict with the first law 3.
How about not, because it's going to take forever.
Good.
Yeah.
All right, thanks.